Ladies and gentlemen, prepare to embark on a cosmic journey that will challenge your perception of our place in the universe. Close your eyes for a moment and picture this. A solar system where 7 planets pirouette around a tiny star, like a miniature version of our own cosmic neighborhood. This celestial ballet unfolds in perfect harmony, each world following its own unique rhythm in a cosmic dance that has captivated astronomers and dreamers alike. Now, open your eyes to an astounding reality. This is not a scene from a science fiction novel or a computer-generated fantasy. This is the TRAPPIST-1 System, a remarkable cosmic arrangement that exists just 40 light-years from Earth, practically our galactic backyard. In the vast tapestry of the universe, TRAPPIST-1 stands out as a beacon of possibility. It's a system that has reignited our imagination and breathed new life into the age-old question: are we alone in the universe? Welcome to the fascinating world of TRAPPIST-1, where the search for extraterrestrial life has entered an exciting new chapter. As we delve into the secrets of this extraordinary system, we'll explore worlds that could potentially harbor the ingredients for life as we know it. We'll witness the delicate interplay between a dim star and its planetary progeny, each one a unique laboratory for studying the potential for life beyond our solar system. But let me ask you this: what if I told you that at this very moment, scientists around the globe are fixated on a solar system that could potentially host not just 1, not 2, but 7 potentially habitable worlds? 7 planets, each one a new frontier, each one a possible cradle for life in the cosmos. The TRAPPIST-1 System isn't just another astronomical discovery to be filed away in the annals of science. It's a window into the future of space exploration, a tantalizing glimpse of what might be possible as we push the boundaries of our knowledge and technology. Who knows? It might even be the key to humanity's first contact with life beyond Earth. As we stand on the precipice of this new era of discovery, TRAPPIST-1 beckons us to look up and wonder. It challenges us to question our assumptions about the prevalence of life in the universe and invites us to dream big about our cosmic future. In the next few minutes, we'll take a closer look at this remarkable system. We'll explore its unique star, examine its 7 intriguing worlds, and consider the thrilling possibilities they present. We'll delve into the latest scientific findings and ponder what they might mean for our understanding of life in the universe. So, fasten your seatbelts and prepare for a mind-bending journey to the edges of our current knowledge. The TRAPPIST-1 System awaits, and with it, a universe of possibilities. If this cosmic journey has already sparked your curiosity, don't keep it to yourself. Hit that like button to help our channel reach more cosmic explorers like you. And if you're ready to dive deeper into the wonders of our universe, make sure to subscribe to Exploring the Universe. Together, we'll unravel the mysteries that await us in the stars. The year 2017 marked a watershed moment in the field of exoplanet research. On February 22, NASA announced the discovery of 7 Earth-sized planets orbiting a single star, the TRAPPIST-1 System. This revelation sent shockwaves through the scientific community and captured the imagination of the public worldwide. The discovery was the culmination of years of painstaking research and observation. It all began with the TRAPPIST telescope, Transiting Planets and Planetesimal Small Telescope, a modest 0.8-meter telescope located at the La Silla Observatory in Chile. Despite its small size, TRAPPIST was designed with a specific purpose: to study nearby ultracool dwarf stars and search for planetary transits. The importance of the TRAPPIST telescope cannot be overstated. Its unique design and purpose-built instrumentation allowed it to detect minute changes in the brightness of dim, cool stars, changes that could indicate the presence of orbiting planets. This specialized focus on a class of stars often overlooked by larger surveys proved to be a game-changer. The initial discovery of 3 planets in the TRAPPIST-1 System was announced in 2016. However, it was the follow-up observations using NASA's Spitzer Space Telescope that revealed the full extent of this remarkable system. 7 planets in total. The reaction from the scientific community was one of overwhelming excitement. Astronomers worldwide recognized the significance of finding so many potentially habitable worlds around a single star. The discovery opened up new avenues for research into exoplanets, planetary formation, and the potential for life beyond our solar system. Michael Gillen, the lead researcher from the University of Liège in Belgium, described the finding as a paradigm shift in our understanding of planetary systems. The discovery of TRAPPIST-1 challenged existing models of planetary formation and evolution, forcing scientists to reconsider their assumptions about the diversity of planetary systems in our galaxy. At the heart of the TRAPPIST-1 System lies a star unlike any we've studied before. TRAPPIST-1 is classified as an ultracool dwarf star, and its unique characteristics make it a fascinating subject of study in its own right. TRAPPIST-1 is remarkably small and cool compared to our Sun. With a radius only about 11% that of the Sun and a mass approximately 8% of the Sun's, it's more akin in size to the planet Jupiter than to typical stars we're familiar with. Its surface temperature is a mere 2,500 Kelvin, less than half that of the Sun. To put this into visual perspective, if we were to place TRAPPIST-1 next to our Sun in the sky, it would appear as a dim, reddish point of light, barely visible to the naked eye. Its faint glow would be easily overshadowed by the brilliant radiance of our own star. Despite its small size and low temperature, TRAPPIST-1 is far from inactive. It's prone to powerful stellar flares, which can release bursts of energy and radiation many times more intense than those from our Sun, relative to its size. The unique properties of TRAPPIST-1 have profound implications for the habitability of its planets. On one hand, the star's low luminosity means that planets can orbit much closer while still maintaining temperatures conducive to liquid water, a key ingredient for life as we know it. This is why the TRAPPIST-1 system can pack 7 planets into orbits that would fit comfortably within Mercury's orbit in our solar system. On the other hand, the frequent stellar flares and the intense radiation environment pose significant challenges for potential life. Planets orbiting so close to their star are likely to be tidally locked, with one side perpetually facing the star. This could lead to extreme temperature differences between the day and night sides of these worlds. Moreover, the longevity of ultracool dwarf stars like TRAPPIST-1 adds another intriguing dimension to the habitability question. These stars burn their nuclear fuel so slowly that they can remain stable for trillions of years, far longer than the current age of the universe. This extended timeline could potentially allow for the long-term evolution of life, even if conditions are not initially favorable. The study of TRAPPIST-1 and its planets is pushing the boundaries of our understanding of stellar and planetary physics. It's forcing us to reconsider what we think we know about the conditions necessary for life and opening up new possibilities for where we might find it in the universe. The TRAPPIST-1 system is a remarkable cosmic septet, featuring 7 rocky planets orbiting their diminutive star in a tightly packed configuration. Let's take a closer look at each of these fascinating worlds. TRAPPIST-1b. The innermost planet, TRAPPIST-1b, orbits perilously close to its star, completing a full orbit in just 1.5 Earth days. Slightly larger than Earth, this planet likely has a scorching surface temperature and may even have a molten surface. TRAPPIST-1c. The second planet in the system, TRAPPIST-1c, is also slightly larger than Earth and orbits its star every 2.4 days. Like its inner neighbor, it's probably too hot for liquid water to exist on its surface. TRAPPIST-1d. This planet is about 30% smaller than Earth and orbits the star every 4 days. It sits on the inner edge of what scientists consider the habitable zone. TRAPPIST-1e. Often considered the most promising candidate for habitability, TRAPPIST-1e is almost exactly Earth-sized. It orbits its star every 6 days and receives about the same amount of stellar energy as Earth does from the Sun. TRAPPIST-1f. This planet is about 10% larger than Earth and orbits the star every 9 days. It's well within the habitable zone and could potentially host liquid water on its surface. TRAPPIST-1g. The second largest planet in the system, TRAPPIST-1g is about 13% larger than Earth and orbits the star every 12 days. It's the last planet firmly within the traditional habitable zone. TRAPPIST-1h. The outermost known planet in the system, TRAPPIST-1h, is slightly smaller than Earth and takes 19 days to orbit its star. It's likely too cold for liquid water, but could potentially have subsurface oceans. One of the most intriguing aspects of this system is the concept of the habitable zone. This is the region around a star where conditions might be right for liquid water to exist on a planet's surface. In the TRAPPIST-1 system, planets E, F, and G are considered to be within this zone, with planet D on the inner edge. This doesn't guarantee that these planets are habitable, but it does make them prime candidates for further study. It's important to note that all 7 planets are likely tidally locked, meaning they always present the same face to their star, much like our Moon does to Earth. This could create extreme temperature differences between their day and night sides, presenting unique challenges for potential habitability. One of the most fascinating aspects of the TRAPPIST-1 system is the intricate orbital dance performed by its 7 planets. This celestial choreography is governed by a phenomenon known as orbital resonance. Orbital resonance occurs when 2 or more orbiting bodies exert regular, periodic gravitational influences on each other. In the TRAPPIST-1 system, This creates a chain of resonances among the planets. For example, for every 8 orbits that TRAPPIST-1b completes, TRAPPIST-1c completes 5, TRAPPIST-1d completes 3, TRAPPIST-1e completes 2, and so on. To visualize this dance, imagine a grand cosmic clock. As the innermost planet, TRAPPIST-1b, completes 8 full rotations, each of its siblings will have completed a precise number of orbits, returning to their starting positions. This creates a harmonious, repeating pattern that's both beautiful and scientifically significant. This orbital resonance has profound implications for the stability of the system and the potential for life. On one hand, these gravitational interactions help stabilize the planet's orbits over long periods, potentially providing the consistent conditions necessary for life to evolve. The resonances also prevent the planets from gravitationally disrupting each other's orbits, which could otherwise lead to chaotic and potentially destructive outcomes. However, these same interactions also cause the planets to regularly flex and stretch as they orbit, much like how our moon causes tides on Earth. This tidal heating could have significant effects on the planet's interiors, potentially driving volcanic activity or maintaining subsurface oceans even on worlds that might otherwise be too cold. The resonant orbits also mean that the planets regularly align from the perspective of Earth, making them easier to study through transit observations. This has been crucial in allowing scientists to gather detailed data about the system. The delicate balance of the TRAPPIST-1 system's orbital dance provides a unique natural laboratory for studying planetary dynamics. It offers insights into how planetary systems form and evolve, and how similar systems might behave elsewhere in the universe. As we continue to study this cosmic ballet, we may gain new understanding of the conditions that allow for the emergence and persistence of life on alien worlds. The quest to understand the TRAPPIST-1 system goes far beyond merely identifying its planets. Scientists are now engaged in an intricate detective work to uncover the composition of these alien worlds, with a particular focus on the presence of water and atmospheres, key ingredients for life as we know it. Recent studies have provided tantalizing clues about the nature of the TRAPPIST-1 planets. Using data from the Hubble Space Telescope and sophisticated computer models, researchers have estimated that the planets are primarily rocky, similar to Earth, Venus, and Mars in our solar system. However, the data suggests that some of these worlds, particularly the outer planets, may have significant amounts of water, up to 5% of their mass in some cases. This is far more than Earth's 0.02% water content. These findings have excited astrobiologists, as the presence of water is considered crucial for life as we understand it. Water acts as a solvent for biochemical reactions, helps transport nutrients, and can shield organisms from harmful radiation. The potential for liquid water on multiple planets in a single system dramatically increases the chances of finding a habitable world. However, the search for definitive evidence of water and atmospheres on the TRAPPIST-1 planets has been challenging due to their great distance and small size. This is where the James Webb Space Telescope, JWST, comes into play. Launched in December 2021, the JWST represents a quantum leap in our ability to study exoplanets. The JWST's advanced instruments allow it to detect the faint signals of light passing through the atmospheres of these distant worlds. By analyzing this light, scientists can identify the chemical composition of these atmospheres, searching for water vapor, carbon dioxide, methane, and other molecules that could indicate the presence of life. Early results from JWST observations of the TRAPPIST-1 system have been nothing short of groundbreaking. In 2022, the telescope detected the presence of carbon dioxide in the atmosphere of TRAPPIST-1b, marking the first detection of any molecule in the atmosphere of a small rocky exoplanet. While TRAPPIST-1b is too hot for liquid water, this discovery demonstrates the telescope's capability to study the atmospheres of Earth-sized worlds. The importance of liquid water for life, as we know it, cannot be overstated. Water's unique properties make it an ideal medium for biological processes. It can dissolve a wide range of substances, facilitating the transport of nutrients and waste products in living organisms. Water's high heat capacity helps regulate temperature, while its ability to expand when frozen, unlike most substances, has profound implications for the development of life in aquatic environments. Moreover, the search for liquid water isn't just about finding environments similar to Earth. Some scientists speculate that life could exist in subsurface oceans on icy worlds, protected from harsh surface conditions. The potential for such environments in the TRAPPIST-1 system adds another layer of intrigue to our exploration. As we continue to study the TRAPPIST-1 system with the JWST and future telescopes, we edge closer to answering one of humanity's most profound questions. Are we alone in the universe? Each new piece of data, each detection of an atmospheric molecule, brings us one step closer to potentially discovering the first signs of life beyond Earth. If you're as awestruck as I am by this unique stellar system, don't forget to hit that like button. Your engagement helps our channel reach more cosmic explorers just like you. Together, we're unveiling the mysteries of the universe, one video at a time. And remember, every like is a small step for you, but a giant leap for our cosmic community. Stay curious, and let's continue this incredible journey through the TRAPPIST-1 system. While the TRAPPIST-1 system offers exciting possibilities for potential habitability, it also presents unique challenges that any life forms would need to overcome. Understanding these challenges is crucial in our quest to assess the likelihood of life in this fascinating system. One of the primary concerns is the radiation environment created by TRAPPIST-1, the system's ultracool dwarf star. Despite its small size and relatively cool temperature, TRAPPIST-1 is known to be quite active, producing frequent and powerful stellar flares. These flares can emit intense bursts of X-rays and ultraviolet radiation, potentially harmful to life as we know it. The planets orbiting close to TRAPPIST-1 could be subjected to radiation levels hundreds or even thousands of times higher than what we experience on Earth. This intense radiation could strip away planetary atmospheres over time, particularly for the inner planets. Any life forms on these worlds would need to develop robust mechanisms to repair radiation damage or find ways to shield themselves, perhaps by evolving to live underground or under the protection of deep oceans. Another significant challenge is the concept of tidal locking, or synchronous rotation. Due to their close orbits and the gravitational influence of their star, all 7 TRAPPIST-1 planets are believed to be tidally locked. This means that they always present the same face to their star, much like how we always see the same side of the Moon from Earth. Tidal locking creates extreme temperature differentials between the day and night sides of these planets. The side facing the star could be scorching hot, while the dark side might be freezing cold. This temperature gradient could drive powerful winds and create complex weather patterns, potentially making surface conditions inhospitable. However, life is remarkably adaptable, and we can speculate on how organisms might evolve to thrive in such environments. In the twilight zone, between the day and night sides, where temperatures might be more moderate, complex ecosystems could potentially develop. Life could evolve to be migratory, following the habitable zones as the planet rotates, similar to how some species on Earth migrate with the seasons. Subsurface oceans, protected from radiation and extreme temperature fluctuations, could provide stable environments for life to evolve. Life forms might develop biological mechanisms to harness the intense stellar radiation for energy, similar to how plants on Earth use photosynthesis. In the case of planets with dense atmospheres, heat distribution could be more even, potentially creating more Earth-like conditions globally. The discovery of the TRAPPIST-1 system has ignited the imagination of scientists and the public alike, spurring plans for future missions and technological developments aimed at unraveling its mysteries. One of the most anticipated upcoming missions is the Habitable Exoplanet Observatory, a concept for a space telescope specifically designed to search for signs of habitability and life on exoplanets. If approved and launched, HabEx could provide unprecedented views of the TRAPPIST-1 system, potentially allowing us to map the surfaces of its planets and detect biosignatures in their atmospheres. Another exciting prospect is the LUVOIR, a proposed multi-wavelength space observatory that could revolutionize our understanding of exoplanets. LUVOIR's advanced capabilities could allow it to directly image some of the TRAPPIST-1 planets, providing detailed information about their compositions and atmospheric dynamics. On the ground, the extremely large telescope, currently under construction in Chile, will be the world's largest optical/near-infrared telescope when completed. Its immense light-gathering power and advanced instrumentation could allow for detailed spectroscopic analysis of the TRAPPIST-1 planets, potentially revealing the presence of water, oxygen, or other biosignatures. Experts in the field are cautiously optimistic about the potential for groundbreaking discoveries. Dr. Michael Gillen, the leader of the team that discovered TRAPPIST-1, has stated that he believes we have a realistic chance of detecting signs of life in the system within the next decade, given the rapid advancements in our observational capabilities. Other scientists speculate that the TRAPPIST-1 system could provide insights into planetary formation and evolution that challenge our current models. The system's compact nature and the resonant orbits of its planets offer a unique laboratory for studying complex gravitational interactions and their long-term effects on planetary habitability. Some researchers are even considering the possibility of sending miniature probes to the TRAPPIST-1 system in the distant future. While such a mission would take centuries with current technology, Concepts like the Breakthrough Starshot Initiative are exploring ways to send tiny, light-sailed probes to nearby star systems at a fraction of the speed of light. As we continue to study TRAPPIST-1, each new discovery brings us closer to answering fundamental questions about our place in the universe. Whether we find evidence of life or not, this remarkable system is sure to reshape our understanding of planetary systems and the potential for life beyond Earth. The exploration of TRAPPIST-1 represents more than just scientific curiosity. It's a testament to human ingenuity and our unending quest to understand our cosmic neighborhood. As we peer into this distant solar system, we're not just observing alien worlds. We're catching a glimpse of the future of space exploration and, perhaps, of humanity's destiny among the stars. The discovery of the TRAPPIST-1 system has profoundly altered our perspective on habitable exoplanets and has had far-reaching implications for the field of astrobiology and the search for biosignatures beyond our solar system. Prior to the TRAPPIST-1 discovery, much of the focus in exoplanet research was on finding Earth-like planets orbiting Sun-like stars. The revelation of 7 Earth-sized worlds orbiting an ultracool dwarf star has dramatically expanded our understanding of where habitable planets might exist. This paradigm shift has several important implications. Prevalence of habitable worlds. Ultracool dwarf stars like TRAPPIST-1 are the most common type of star in our galaxy. The discovery that such stars can host multiple potentially habitable planets suggests that the galaxy might be teeming with worlds capable of supporting life. This has led to a re-evaluation of estimates for the number of potentially habitable planets in the Milky Way, with some scientists now believing there could be billions of such worlds. The compact nature of the TRAPPIST-1 system has forced scientists to reconsider the traditional concept of the habitable zone. The planets in this system receive very different types of radiation compared to Earth, yet several of them could potentially support liquid water. This has broadened our understanding of the conditions under which life might emerge and thrive. The TRAPPIST-1 discovery has highlighted the significance of M-dwarf stars in the search for life. These stars, once considered less promising for hosting habitable planets due to their faintness and propensity for stellar flares, are now at the forefront of exoplanet research. The impact on astrobiology and the search for biosignatures has been equally profound. The unique conditions in the TRAPPIST-1 system have spurred the development of new models for planetary atmospheres around ultracool dwarf stars. These models take into account factors such as tidal locking, intense stellar flares, and the different spectrum of light emitted by these stars. Astrobiologists are now considering a wider range of environmental conditions that could potentially support life. This includes scenarios such as tidally locked planets with narrow habitable zones, worlds with subsurface oceans, and even atmospheres very different from Earth's. The search for life in the TRAPPIST-1 system has encouraged scientists to think creatively about potential biosignatures. For example, on tidally locked planets, the interplay of light and shadow could create unique chemical signatures in the atmosphere that might indicate the presence of life. The challenge of detecting biosignatures in the TRAPPIST-1 system has driven rapid advancements in observational techniques and technologies. This includes improvements in spectroscopic analysis, the development of new algorithms for data processing, and the design of future space telescopes optimized for exoplanet characterization. The complexity of the TRAPPIST-1 system has fostered increased collaboration between astronomers, planetary scientists, geologists, and biologists. This interdisciplinary approach is crucial for understanding the potential for life in such alien environments. The discovery of TRAPPIST-1 has captured public imagination, increasing interest in astrobiology and the search for extraterrestrial life. This has led to greater support for space exploration and exoplanet research. The possibility of finding life in the TRAPPIST-1 system has reignited discussions about the potential impact of discovering extraterrestrial life. It has prompted reflection on humanity's place in the universe and our responsibilities as we explore these distant worlds. The TRAPPIST-1 system serves as a cosmic laboratory, allowing us to test and refine our theories about planetary formation, evolution, and the conditions necessary for life. Each new piece of data we gather from this system brings us closer to answering one of humanity's most fundamental questions. Are we alone in the universe? As we continue to study TRAPPIST-1 and other similar systems, we're not just expanding our scientific knowledge. We're embarking on a journey that could fundamentally change our understanding of life itself. The search for biosignatures in these distant worlds is more than a scientific endeavor. It's a quest to understand our place in the cosmos and the ubiquity of life in the universe. As we conclude our journey through the TRAPPIST-1 system, it's important to reflect on the profound significance this distant solar system holds for humanity. TRAPPIST-1 is more than just a collection of planets orbiting a dim star 39 light-years away. It represents a paradigm shift in our understanding of the cosmos and our place within it. For centuries, humanity has gazed at the night sky, wondering if we were alone in the universe. The discovery of TRAPPIST-1 brings us tantalizingly close to answering that age-old question. This system challenges our preconceptions about where life might exist. It reminds us that the universe is far more diverse and full of possibilities than we once imagined. The fact that a tiny, cool star could host not one, but 7 Earth-sized planets, several of which could potentially harbor life, expands our horizons and forces us to reconsider our definitions of habitability. TRAPPIST-1 also serves as a testament to human ingenuity and perseverance. The discovery and ongoing study of the system push the boundaries of our technological capabilities. It showcases our ability to peer across vast cosmic distances and discern the nature of worlds we can barely see. This achievement stands as a beacon of what we can accomplish when we apply our collective intelligence and resources to exploring the unknown. Moreover, the study of TRAPPIST-1 underscores the importance of continuing our cosmic exploration. Each new discovery about the system not only answers existing questions but also raises new ones, fueling our curiosity and driving us to probe even deeper into the mysteries of the universe. It reminds us that the journey of discovery is ongoing, and that there is always more to learn and understand about our cosmic neighborhood. As we contemplate TRAPPIST-1, we're invited to imagine the possibilities it represents. What might life look like on a tidally locked planet, with one side in perpetual day and the other in eternal night? How might intelligent beings evolve in a system where 7 worlds dance in close proximity? Could there be civilizations gazing back at us, wondering about the pale blue that they see in their night sky? These questions may seem like science fiction, but TRAPPIST-1 brings them into the realm of scientific inquiry. It challenges us to expand our imagination while grounding our speculations in rigorous observation and analysis. TRAPPIST-1 embodies the spirit of human exploration. It represents our unquenchable thirst for knowledge, our desire to push beyond known frontiers, and our ability to find wonder in the cosmos. As we continue to study this remarkable system, we're not just learning about distant worlds. We're learning about ourselves, our place in the universe, and the boundless potential of human curiosity and determination. The exploration of TRAPPIST-1 is more than a scientific endeavor. It's a journey that connects us to the grandeur of the cosmos and reminds us of the extraordinary universe we inhabit. It invites us to look up at the night sky with renewed wonder, knowing that among those distant points of light, there are worlds waiting to be discovered and mysteries yearning to be solved. As we move forward, let TRAPPIST-1 serve as an inspiration, a reminder that the universe is vast, wondrous, and full of surprises. Let it motivate us to keep questioning, exploring, and pushing the boundaries of our knowledge. For in doing so, we not only unlock the secrets of distant worlds but also discover the limitless potential within ourselves. If this journey through the TRAPPIST-1 system has ignited your cosmic curiosity, don't let the exploration end here. Subscribe to the Exploring the Universe channel to continue unraveling the wonders of our vast cosmos. Each video is a new adventure, a chance to voyage to the farthest reaches of space and time from the comfort of your screen. By clicking that subscribe button, you're not just joining a channel. You're becoming part of a community of cosmic explorers, united by our shared fascination with the universe. Together, we'll dive into black holes, surf the waves of gravitational fields, and walk on the surfaces of alien worlds. Remember, every great discovery begins with curiosity and the willingness to explore. Who knows? The next video you watch might inspire the question that leads to humanity's next great breakthrough in understanding our cosmic home. So, are you ready to continue this incredible journey? To keep pushing the boundaries of human knowledge? To be part of something greater than ourselves? Then hit subscribe, turn on notifications, and let's embark on this cosmic adventure together. The universe is waiting, and there's so much more to explore. Exploring the universe, where every video is a launch pad to the stars. Join us, and let's unravel the mysteries that await us in the vast expanse of space. The journey of discovery never ends. It only grows more fascinating with each new horizon we reach. See you in the next video, fellow cosmic explorer.